أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم السلام عليكم ورحمة الله وبركاته. I welcome you all to this channel, and in today's problem we have a problem related to instantaneous velocity and acceleration. Let us read the problem. Problem 2 says the displacement of a particle is given by the equation, meaning this is the equation that represents or describes the motion of the particle. X is the displacement of the particle, and at any moment, at any instant you want to get its displacement, you use this equation. 1 seconds after, you substitute t 1 for t here to get the displacement. 2 seconds, you do the same. Calculate its velocity and acceleration when t is 1 second and when 1 second and when t is 2 seconds, meaning calculate the velocity of the particle at the instant when the time is 1 second after the journey started or 2 seconds after the journey started, and do the same for acceleration. B part of the problem says the acceleration of a particle is given by the equation. This is the equation. The acceleration is also time dependent. Okay, a equals 2 plus 5t squared. Find its velocity after 3 seconds. What will be the velocity after 3 seconds? Okay, without any delay, let us start solving the problem. We are going to start with problem 1, A part of the problem. The first thing we are going to do is to write this expression we are given, this very one that describes the motion. The displacement of the particle at any instant equals 20t plus 6t raised to the power of 4. Now we are going to derive two expressions, one for the velocity and two for the acceleration, using this equation we are given. So to get the velocity, we say that the velocity is the first derivative of x with respect to t, meaning v is dx dt. So I continue and say d dt. Instead of x, I will now write this expression on the right hand side, 20t plus 6t raised to the power of 4. Everything in the bracket is my x here, so this is why in the next step I remove the x, and in its place I put the right hand side of this equation I am given. Moving on, I now have to differentiate this individually each time. So I will say d dt. I will I will now take the derivative of this 20t with respect to t, plus then the derivative of what I have here, 6t raised to the power of 4, also with respect to t, and this is equal to, okay, remember this rule for finding the derivative of a function. If I have y equals ax raised to the power of n, then my dy dx equals, I will now bring this a to multiply the constant, so n a, and then I will keep the n there and reduce it by 1. So if I do the same thing here, this will give me, if I bring 1 here, because the power here is 1, so if I take 1 times 20, is going to be 20. Then if I reduce it by 1, then it will be t raised to the power of 0, and any number raised to the power of 0 is 1, so 20 times 1 is 1, so I just have 20, plus, now I will take this 4 and multiply it by 6t, and then I keep the 4 there and reduce it by 1. This is equal to 20 plus 4 times 6. 4 times 6 will be 24. So t 3 at 4 minus 1 is 3. So this is the expression for the velocity. I'm going to say therefore Okay, I will call this equation 1. Then my new equation for velocity will now be equation 2. 20, I will say 20 plus 24 t raised to the power of 3, and I will call this equation 2. So I got the expression for equation for the velocity. Now I will do the same for the acceleration. How do I get the expression for the acceleration? Okay, here is what I'm going to do. For the acceleration, I will say a is equal to dv dt. This is d dt. Since I have v here, let me bring this back. I will take the expression for v from equation 2, 20 plus 24 t raised to the power of 3. So I will now put open bracket 20 plus 24 t raised to the power of 3, and then close bracket. Okay, remember this is a polynomial, so I will differentiate individually. So this is equal to d dt of 20, meaning I will get the derivative of this 20 plus d dt 24 t raised to the power of 3. You see, the derivative of a constant, it has no t here, so the derivative of a constant is 0. I have 0 here, plus, and then this one I will bring this 3, I will multiply it by 24, and I have this t with a power of 3 reduced by 1, and this will give me, okay, this should give me 72. This is 0, so 3 times 24, I have 72 t, 3 minus 1, 2. Therefore my expression for the acceleration is 72 t raised to the power of 2, and I call this equation 3. Okay, now if I want to find the velocity after 2 seconds, if you look at the problem, it said velocity and acceleration when t is 1 second and when t is 2 seconds. So I'm going to take the 1 second first. So we will now say when t is equal to 1 seconds, comma, then from our expression for velocity, you see we did it before, our v is equal to 20 plus 24 open bracket. Instead of this t, I will now write the 1 second I have here, so 1 close bracket, I put a power of 3 here, so this is equal to 20 plus 1 raised to the power of 3 is 1. 1 times 24 is 24, so I have 20 plus 24, which will be 44. Remember, you now ask yourself, what quantity am I calculating? The quantity is velocity, and the unit of velocity is meters per second. So I have meters per second. Again, when t is 1 second, I need to find the acceleration. I need to find the acceleration. A equals, this is the expression for acceleration according to equation 3. This is 72 into instead of t, I will now put 1 here, substitute 1 for t. I have a power of 2 here, so I will have a 1 raised to the power of 2 is 1 times 72 is again 72. My quantity is acceleration, and the unit of acceleration is meters per second squared. So with this, we have successfully solved the A part of the problem. Then we move on to the B part. Okay, moving on to the B part. If you look at the B part, we are given the expression for the acceleration, and we are asked to get the velocity. So what we are going to do here is we are going to transform the equation we used before. We know that acceleration is the first derivative of v with respect to t. So this implies that I can write this dv in terms of a and dt. I will multiply a by dt, and I have a dt. Now this means small change in velocity. If I want to get the complete velocity, I will take the integral of both sides. This is dv and this is a dt. Now sorry, integral 2, I put integral here. So integral dv will just be v, okay, meaning the complete velocity I have, and this is equal to, then on this side, my a, I am given the expression for a in the problem. What is the expression for a? Look at it here. They say a is equal to 2 plus 5t. So this one here, what you have here, 2 plus 5t squared, is my expression for a, and I will open bracket and put 2 plus 5t squared, close bracket. Then I have my dt. Okay, moving on. This one I will have to integrate differently or individually. I will take 2 and integrate, then plus this one too, I will integrate it. So I will have integral 2 dt plus then integral 5t squared also dt. Okay, moving on. uh, the integral of a constant will just be 2t. I will multiply it by the independent variable t. So 2 times t will be t. Then plus, how do I integrate this one? The integral, it will be, I will keep my 5, okay? Then I will integrate this one. I will increase the power of t by 1, sorry, 2 plus 1, and then I will divide it by the whole 2 plus 1, the whole power of t I have. You see, so this will now be, this is equal to 2t plus 2t plus 2 plus 1, 3. So I will have 5 divided by 3, and the numerator 2 plus 1, 3. So I have t squared, t raised to the power of 3. So this is my expression that I am going to use to calculate my acceleration. Remember, they say we should get this. I'm sorry that I'm going to use to calculate velocity. Okay, I just found it for velocity. So find its velocity after 3 seconds. So after 3 seconds, you just put 3 here for t and get your velocity after 3 seconds. So let's see that. Oh, let us rewrite this for expression for v is equal to 2t plus 5 upon 3 t raised to the power of 3. So this is our formula for calculating the v. This is equal to 2 into, because they say after 3 seconds, so we put 3 here, okay, for the t, plus 5 upon 3 into my t is 3 seconds, close bracket, and I have a power of 3. Okay, wow, I like that. So this is equal to, if this will give you any difficulty, my advice is that you take your calculator and you press 2, this is 2 open bracket 3 close bracket, so 2 open bracket, oh, I did not switch it on. So I have 2 open bracket 3 close bracket, then I have plus plus, okay, then this one is the numerator, so I will say 5 open bracket 3 again close bracket raised to the power of 3, so raised to the power of 3. Then I divide this one by I have 3 under here, so I will divide it by 3, and it will give me the result directly, which is 51. So my result is 51. Remember, the quantity you are calculating is velocity, and velocity is measured in meters per second. So our answer is 51 meters per second. After 3 seconds, its velocity will be 51 meters per second. With this, we have successfully solved problem 1, and I hope it's clear to all of you. If there is any part that you begin to feel lost, please let me know. You can ask question on the comment section. Thank you. Assalamu alaikum wa rahmatullah.